Welcome back to Through Inquisitive Kids. In this video, we'll be starting Chapter 9 of our Grade 7 math lessons. And we will be starting to talk about variables and tables. And our course outline for this unit is actually very short. It only consists of 4 separate videos. This is Lesson 1 of Chapter 9. Our learning goals for today is to understand the meaning of constants and variables, and understand the meaning of independent and dependent variables. We also want to be able to determine the relationship between variables from a table and to make a prediction from the changing trend. So what will happen next based off of the pattern we found? Well, we live in a constantly changing world, and many things are quietly changing. Can you give some examples from our daily lives? For instance, in this example, they are talking about the average height when boys and girls are growing. So usually girls start growing slightly earlier than boys. That's why at first, when you're 11 to 13 years old, it may seem like all the girls are taller than the boys. But then after that, the boys start growing. And here, a planet's position in the universe changes over time. And as you get higher up a mountain, the temperature gets colder. And if you're driving a car, the longer you drive, the further you have driven. Here we have a newborn baby. When it is 6 days old, it is about 2 times its weight at birth. When it grows to be 1 week old, it becomes 3 times its weight at birth. And when it becomes 2 weeks old, it becomes 4 times its weight at birth. So which of the quantities were changing in this example with the newborn baby? Well, we know that its weight was changing because as it got older, it became heavier. And we know that a baby weighed 2.5 kg at birth. Fill in the following table with the given information. So at birth, we already know that it's 3.5 kilograms. Then after 6 days, if you want to, you can go back to the previous slide of the video. It would be 7 kilograms heavy because it is 2 times its weight at birth. And you keep following the pattern and the rules they give you. So by 10 weeks, it would have grown to 31.5 kilograms. According to the data in the table, how did the weight of the child change from birth to 10 weeks old? So can we find any pattern? Well, when we went from its birth to 6 days, you can see that it increased by 3.5. When it went from 6 days to 1 week, it added 3.5 kg, and so on. Common study groups did an experiment to keep track of how long it took for the toy car to slide down the ramp. Using the same ramp, the team measured the time for the car to slide down from different heights, and then filled in this table. So here's what they ended up with. When the ramp's height was 10 centimeters tall, the time it took for the car to slide down was 4.23 seconds, and so on. When the ramp is raised to 70 centimeters, what is the sliding time of the car? So I want you to use this table. Well, when you get into this column, you can see that the sliding time was 1.59 seconds. And here you're seeing the difference between each of these values. As you can see, the time is getting shorter and shorter, so the car is starting to slide down faster and faster. And our answer for this first question is 1.59 seconds. If h represents the height of the ramp and t represents the sliding time of the car, then how does t change as h gradually increases? So t would be decreasing as h increases. The higher you raise the ramp, the faster the car goes, which means that the car takes less time to slide down the ramp. When h increases by 10 centimeters, does t also increase by 10 centimeters? No, it doesn't. Number 4. Estimate the value of t when h equals 110 centimeters. How did you do it? If you want to go back to the previous slide and pause the video, feel free to do that. Well, then t would be about 1.30 seconds because the time decreases at a constant value. As you can see, the time changes, so how long it takes for the car to slide down changes, but the length of the ramp never does. So in this case, the time would be a variable, I'll write v for short, and the length of the ramp would be a constant. The height of the ramp, I don't know why it says object, is an independent variable. and t is a dependent variable. The distance the car slides, the length of the ramp, has not changed. So a quantity whose value remains constant throughout the process is called a constant. As you can see, Kanban's theme is the one that's constantly changing the height of the ramp. So the height of the ramp is the value that's being directly changed. But the time only changes because the independent variable changes. A country's population statistics from 1949 to 1999 are as follows, and this is rounded to the nearest 0.01 million. And I want you to observe this table. If you want to come back to it when we get to the problems, feel free to do that. Let x represent the time and y represent the country's population. How does y change as x increases? As you can see, the number of people in this country gets bigger and bigger. Out of x and y, which one is the independent variable? Which one is a dependent variable? Well, x would be the independent variable. That's the year we are talking about. And y is the dependent variable. That's the country's population. Starting from 1949, how did the population change every 10 years? Well, the population increased. Based on the table, can you predict what the population of the country will be in 2009? So in 2009, it would be more than 1.3 million people. So that's a lot of people. Karen told Kanban, the further away you are from the ground, the lower the temperature will be. She showed Kanban the following table. So when you're 0 kilometers away from the ground, the temperature would be 20 degrees. And right now we're talking about in Celsius. If h represents your height from the ground and t represents the temperature, how does t change as h changes? Well, as h increases, t decreases. The reason t decreases is because it gets colder and colder the higher up you go a mountain. What is the temperature at 5 kilometers above the ground? Negative 10 degrees Celsius. You could go back and refer to the table. Can you predict what the temperature will be at 6 kilometers above the ground? Well, based off of the pattern we found in the previous table, you can feel free to go back to the previous slide if you want. The temperature at 6 kilometers above the ground would be negative 16 degrees Celsius. Here's our class summary. That was a very quick lesson. Today we learned about variables. We learned what an independent variable is and what a dependent variable is. The independent variable is a quantity that changes actively within a certain range. The dependent variable is a quantity that changes when the independent variable changes. And we know that a table can represent the relationship between the dependent variable and the independent variable. And when we study a table, we can make accurate predictions on what will happen next based on the changing trend. So I hope you learned something from this video, and be sure to come back for the next lesson.